a problem session before a final exam. Y'all got that? What else you got for me? Because the quicker we do this, the better. My leg's hurting right now, and I want to get it propped up as. Come on, guys. What else you got for me? What about transmission line? Any question about that?
Yes, I do have a question. I was working through some old homework problems, and
Hold on.
homework 3, you assigned problem 2.27, and to not use the Smith chart, to do it by hand.
2.27, this one?
Yes.
All right. Now, they said for this one right here, what it's going to amount to is you're going to have the equation for the input impedance. Do you all remember that?
Yes, sir.
Zn is, all right, so go ahead.
But I was good up until C. I was having trouble because in the homework you said to first try to solve them, like not using the Smith chart, just through equations. And I ran into problems on the part C finding Zn.
Zn? Okay.
Yes.
I'm gonna do this. All right, I'm gonna put it down here. When we have this, if y'all can see this, let me. If you can't, just let me know. I prefer to put it here. You'll have a permanent record. All right. So in general, if we're talking about a Smith chart, and we want a transmission line, we want the input impedance. We know the length. We know beta on the line. We know the load, and we know the characteristic impedance. Right.
Yes.
All right. That means we know that Z is a function of L. That would be the length of the line, would be equal to first Z naught, right? Then it's times Z sub L. Y'all with me on this? Then it's plus, and we're assuming it's lossless.
Yes, sir. It is lossless.
Yeah, J times what? Z naught again, right?
Yes, sir.
Then it's going to be times the tangent of beta on the transmission line times L, length of the transmission line, right?
Yes, sir.
And then it's divided by, and then it's going to be Z sub naught, pardon me, right? Plus J times Z sub L, right? The load. And then it's going to be times tangent of beta L, right?
Yes.
And that would be the input. Now, if you want the input to this input impedance, well, you just put in L. If you have Z naught and ZL, you put in L. Follow me?
Yes, sir.
That's how you do it.
Yes, sir. Honestly, I think it's just calculation problem.
Well, remember, now this is something I try to stress. These are in radians. Beta is radians per meter. L has to be meters. Remember that. You're going to take the tangent in radians, okay?
Yes, sir.
That's usually a problem. I know a lot of people had that problem.
Yes, sir.
Okay. We good with that?
Yes, sir. That was my only question.
All right. What else you got for me? How about you, Fowler? You got anything?
No, I'm good.
All right, Kenny, do you have anything for me? Can you hear me, Kenny?
No, I've just been going back. Yeah, I can. I've just been going back through quizzes and homeworks.
John? You good? Tyler? Let me make one point, all right? I kind of put this together, this final, and I want to make sure I just tell you so we're straight. Smith charts, transmission lines, you got to know it, okay? No question. The electric field from a static charge, electric field or D field using Gauss's law, got to know it. We good on that? Everybody? H field or B field from symmetric currents, like cylinders of current. For instance, a cylinder of current where the current density changes, got to know it. With me? Everybody hear that? If we have different structures with resistance and capacitance, for instance, if you have spherical cylinders, or just planar structures, you should be able to quickly get the capacitance and the resistance. Now, if something varies spatially, listen to me. For instance, if conductivity or permeability or resistivity is a function of the spatial distance, then what you have to do is go ahead and, for instance, I'm just going to try to tell you this. If it was a resistance problem, y'all listening? Suppose in a resistance problem, the value of sigma is a function of space. And I'm just going to make up something here. Matter of fact, if you guys don't mind, I'm going to write here because this would be quicker for me. It's hard for me to draw with this thing. I wish I was better at this, but I'm not. So let me put this down. I wonder if this thing's on. It is, by God, it is. Hallelujah. All right. Suppose this happens, all right? Suppose I have a cylinder. Got me? Call this Z equals 0 and Z equals L. And the area of that thing is a constant, whatever it is. So there's cross-sectional area is a constant. Now listen. And I want to know the resistance between this side and this side. If inside here, sigma is equal to some sigma naught, all right, times Z. Now think about it. That Z equals 0. Sigma here is 0, isn't it? Z equals 0. This is sigma naught times Z is equal to the value of sigma as a function of Z. Can you all see this, class? All right, what happens? Conductivity is going up, right? Now for a problem like this, and there's going to be a problem like this, and it could be something where it's going to, I would want the resistance between an inner and outer cylinder. It could be along the line. It could be between an inner and outer sphere. You all hear me now? All right. Now here's how you always do this thing. We don't know what that voltage is, but we assume a current. Usually we start by assuming a current. So we assume I, right? I comes up here and it's uniformly distributed across the cross section. Does everybody follow me on that? Aran, can you understand me? And Kenny, you guys hear me? Now, if it's uniformly, so I'm assuming I, now I get J. What is J always equal to? What about it, Caleb? What is J, the current density, equal to if it's uniformly distributed over the surface area? Anyone? If you don't know it, how about you, Johnny? John, what is it?
I over A.
It would be I over the cross-sectional area A, and it would be in the AZ direction. That's sort of implied though, right? Now, once we have J, what do we get? We're after resistance, class. We get E, right? And what's E, anyone? It's J divided by sigma, correct? Now we got J right there. There's sigma, so this is divided by sigma naught Z, correct? All right. I should say one other thing. Let's not make Z equals 0. Let's make it 0.01. Because if I make this 0, it's going to mess up. So it's really, this is going to be sigma naught Z. And it would be in the AZ direction, correct? Now remember, J is just I over A. Y'all hear me now? Now, what's the next thing I get? Voltage. And what is voltage? It's really the integral of E dot dl, right? That will be strict positive. So that's the integral of E, which is going to be J, which is just a constant. It's I over A, divided by sigma naught Z in the AZ direction. And dl would be this way. It would be dl here would be equal to AZ dz. Do y'all see that, class? So I dotted into AZ dz. And I'd integrate it from 0.01, 0.01 to L, whatever L is. Now you'll notice when I do that, I get V is equal to J, right? That's a constant, over sigma naught. And then az.az is 1. And when we integrate 1 over z dz, we get the natural log of L over 0.01, correct? Y'all follow me? Take a good look. Can you see it, John?
Yeah, could you go over your differential length again?
Yeah, differential length is in this direction. I want the voltage between here and here. I call this the z-axis. So the differential length would be equal to AZ. It has to have a vector sense, DZ, right? All right. Now that means the AZ's cancel and I'm just integrating DZ. I'm sorry if this is not drawn very well. Now, J, I'm going to put in J. J was equal to I over A, right? And times the natural log of L over 0.01. Y'all with me? You'll notice I assumed I got J, got E, then I got V. Finally, the last thing is resistance is equal to what? V over I, isn't it? So when you do that, what happens? That's V. If I divide by I, I get 1 over A sigma naught natural log of L over 0.01. Y'all see that? So I know how to do that for, like, if it's in, if the variation is radially or if it's along the length. And I'm trying to give you a tip here. Are you good on that, guys? All right. For magnetics, remember there's magnetic boundary conditions, right? And you have to be able to calculate the magnetic field using Ampere's law. Remember that for symmetric systems. Y'all have done that a lot, right? Y'all with me, guys? And for capacitance or inductance, you know, you always do what? Like for capacitance, you would assume charge or voltage, one of the two. Probably charge, then you calculate the D field, then you calculate the E field, then you calculate the voltage, and then you can say capacitance is Q over V, right? Remember how to do that? Same thing, just like resistance. You assume something and work towards the definition. And if you wanted inductance of something, then you have to understand flux linkage if it's term stuff, right? And if it's just some kind of volume with a current density or with something, you have to find the H field. And remember, magnetic energy is 1/2 mu times H squared. Remember that? And you would integrate the magnetic energy density. All right. If you guys have been keeping up with this, you should be okay.
Are there going to be transients?
Huh?
The transients problems?
You mean transmission line transients?
Yeah, kind of. Yeah.
Chapter 3 or chapter 2 or where?
Looking with chapters.
It's chapter 2.
What Homer? Oh, you mean on the transmission lines?
Yeah, where it's like the reflection back and forth.
No, I didn't do any. I did a bounce diagram or two, but I'm not going to give you that. All right.
Okay.
All right. All right. Anything else? Carlin, did you have a question? Can you hear me?
No, I don't.
Anybody else got a question? My leg's hurting right now. I'm trying to do my job. And the final tomorrow's at 8, right? What I'm going to do is send it to you about 7:45, and I'll give you an extra 15 minutes. I mean, you'll have plenty of time. But I want you to make sure when you do your work, you do it neatly. All right. You put your answers in the upper right-hand corner. I may not have specified that on the exam last time. In the upper right-hand corner and box them. And please be very neat, because on a final exam, there's not much room for extra credit unless it's very obvious. Got me on that, everyone? Any other questions? Before I came here, I have to walk several times a day. And I went for about 15, 20-minute walk and I got back. So my leg is just pounded with blood.
So, Professor, the exam should be about 2.5 hours or something. Is that right?
Oh, no. That's the limit of time. Most of the people, you're not going to need that much time. If you know what you're, I mean, you can read the book, you can read an entire chapter in an hour and try to figure things out. If you know what you're doing, this will be over in an hour and a half, guaranteed. If you don't know what you're doing, you can take 5 hours and probably not get it. It's going to be, you know how my exams are in quizzes, right? They're reflective of the homework and really, I hate to say this, but you have to show me you know what you're doing. You're not going to just guess something and hope for credit. You're not going to get anywhere with that. If you know what you're doing, it'll be clear to me. And if you don't, it'll be clear to me, I think.
Yes, sir.
Now, I want to tell you, I'm sorry I didn't get this graded. My leg has been, been having a problem. I will get that. I went over it though, and I will get your homework back to you, promise. And I'll get your final as soon as I can. The last day of finals is Wednesday, isn't it?
Yes, sir.
And I don't know, when is graduation? It isn't. We canceled graduation. But I think I get at least Thursday to do grading because I got an exam on Wednesday. And it is a pain in the butt to grade the way I grade. I know some people use multiple choice, but I will not do that. I think it is wrong in a very fundamental way for any engineer to be given a multiple choice test. That's just my opinion. Now, how many here are in Auburn? 1, 2, 3. All right, so we got 3 out of 7, is that right? Or 6? 6. I don't know where the other people are. Tyler, could you make sure you connect with the other people and they know there's a video here for questions, please?
Yes, sir, I will.
Any other questions at all, guys? This is my one tip to you. When I was where you're at, the one thing that saved me, and I got it from a German professor named Hagenbuch, said, get your sleep. An hour or 2 extra sleep will do more for your analytic abilities and memory than staying up an extra 2 hours cramming. I don't care how much coffee and speed you take. I'll tell you this story and don't repeat it. I had a kid, a final exam. First, he told me, I think before, you know, I take, it's either Adderall or some stimulant. He says, and I can remember everything. And he was very confident. So I came in the final exam and he took it. I don't remember everything that happened. I don't even remember his name. But I remember with confidence, he believed he had everything right. And he blew everything. I mean, not just a little. He has confidence he had it right. He didn't even wonder. And it's like the whole test is a mess. I don't know what happens when you're on these drugs, but I can tell you that, talk about false sense of assurance. So sleep is imperative. The only known stimulant that actually doesn't cause all sorts of neurosis and confusion is benzodrine, and they probably have derivatives of, that's what our bomber pilots used in World War II. You can't get benzodrine over the counter. So I'm telling you that is from what I've heard, and I know people that are in the military. Sleep is essential. You really want to foul yourself up? Go ahead and stay up all night and see what happens. Now, I don't have any suggestion for how you get to sleep at night, but I'll say the hour before you go to sleep, I wouldn't study. I'd go for a walk, play pool. Well, you can't play pool. Do something, but try not to get too wound up. And I've been getting a whole bunch of stuff about I have to send out the modalities I'm going to use for my courses and all that. Are you guys getting that online? You getting questions from profs or not? We're supposed to poll our students and find out what they want. Not you guys, my next class. And I'll be doing that shortly, but I'm kind of laughing at this because it seems much to do about nothing. I think everybody knows we're going to be sheltering at home after the first week or so. I mean, I'm hearing this everywhere. Anything else? Caleb, do you have anything for me?
Yes, sir.
Nothing? Kenny? Haran?
I think
Harlan?
No, sir.
Fowler? John? Tyler?
Not
Nothing.
if you'd like to show us the test early.
That's a good question. One other thing too, you have to have your cameras on tomorrow, okay? I'd probably be sitting in a recliner drinking coffee, but you have to have them on and I have to see your face. And I'm not, this is one of those things, you're on your honor. There's certain things I can't, enforce, but I'm really hoping you are. And I enjoyed this semester. You're done scoring me or whatever they call that thing where you do the teacher evaluation. I'm leveling with you. I tried, and I can tell a lot of people were they tried, and I got a lot of questions in different ways. But if you have specific, really comments or suggestions, then just send them to me by email now. I don't think you can put it, you're done with those comments on that teacher evaluation. Just send them to me because I really appreciate that. Most of the time, the most useful things I've found out is when students send me an email and describe why something would work better, and I try to do that. Okay? Guys, take care of yourselves, stay safe, and get your sleep. Please get your sleep. It would save me a lot of anguish too. All right, do me a favor, Tyler.
Yes, sir.
All right, tomorrow at about 7:45, call me. Make sure, for whatever reason, that my internet isn't down, that everything's up and running, because this is the one thing I've heard. Something about final exam week when everything's pushed to the limit, and all of a sudden, everything seems to freeze up. Now, I don't know that for a fact, but I heard that last semester they had some problems. Did anybody else hear this? This is during finals last semester. And worst case, if it's that way, I'll send you stuff on Gmail that you can do and send it back on Gmail. This is the fail-safe method. If everything fails at Auburn, that's what I'll do.
Yes.
All right.
I do actually have a question. For the final, will it be like with the quizzes? You'll email us the final, and then
Yeah.
we'll make a Word document and post it and submit it on Canvas.
Tomorrow, 7:45, I'll send out the final exam. If you can print it, print it. If you can't, make sure you legibly put problem on and very neatly show any work that you want me to consider. Problem 2, have them on separate pieces of paper, white or yellow paper, not green with red crayon or something like this. I had a girl doing this, driving me nuts. I couldn't tell what she's doing. Don't use pencil. All right, use felt, dark markers, dark pens. Make sure you take pictures and put them on a Word document, and you'll upload it to Canvas, and I'll make sure that's ready for you, okay?
Yes, sir.
Oh, I don't think this is a problem, but make sure your calculators are charged. Sometimes I've had people with dead calculators. You're not supposed to be on the internet tomorrow or use your computers. You have to be on the internet to get this thing, but I'm just saying they don't want you using internet resources. I don't know, make a pot of coffee at 7:30 if you drink coffee or tea. That's my advice. And eat some breakfast. Anything else, guys? I mean, if you get hung up on something, you can shoot me an email. I'll probably get to it tonight, but I can't promise you. Okay. Now, I don't know where the other people are, but make sure that they know that there's going to be a video recording of this and that they have access to it. Okay. Who else is missing? I'm trying to figure it out. We're missing people. I don't know who it is.
Ben and Yaping. I'm not sure who else.
Well, we're missing some people. That's okay though. Are you good to go, guys? Y'all stay safe. And if there's any news for the better, or for the really good of the group, or anything like that that you think can help us or we should know about, send me an email or just make sure everybody knows, because this is unprecedented. I think everybody's been encouraged to try to interact as much as possible to help one another. And by the way, when is the end of semester scheduled for the technical end? Do you know? It's usually commencement, day before commencement, but now I don't even know when that day is. No, don't worry about it. I'll get your grades as soon as I can and get it to you. And they'll be in, as soon as I get them all up on Canvas, I'll shoot you an email, okay?
Yes,
Or on Banner, pardon me, Banner. All right.
Thank you.
All right. Take care, guys. Get some sleep. We'll talk to you tomorrow before 8.
Yes, sir. Thank you.
Take care, guys.